All right. Welcome to the FASRC training, getting started with the FASRC clusters with the command line interface. My name is Brad Spitzbart. I'm a facilitator with FASRC, and also my colleague Muniba is here to assist and answer any questions. So feel free, if you have any questions, you can put them in the chat and we'll try to answer them as we go along, or at the end. There'll be plenty of time for questions at the end, or even trying things out. I think we're a small group today, so we'll be a little bit informal. So today we're going to go over logging in via SSH to Cannon and FASSE, and then talk about how to run jobs, both interactively and as batch jobs, non-interactively. We'll talk a little bit about checking the status of your jobs and the performance of jobs, and then also how to install your own software or use the software that we already have on the cluster. So first of all, to log in, we'll give you the documentation reference here. All of this is on our docs site, so please refer to that. If you need reminders on how it is, once you go through it a few times, almost becomes natural. So to use SSH, you will open a terminal on your local machine, whether that's Mac or Linux or Windows, and use the SSH command. It will prompt you for a password, but you won't actually see your password when you type it in, just in case, so you don't have to worry about anyone looking over your shoulder or anything. It'll also ask for your 6-digit two-factor authentication code, which we're assuming you've already set up in Duo and have access to either on your phone or the desktop app. I know a lot of the university has switched over to using Okta or a passwordless code. We're still using Duo, so it's a little bit different, just so there's no confusion there. Still use your Duo two-factor code. And it's separate from any other code for your Harvard key or whatever else authentication that you have set up for. So look for the login.rc.fas.harvard.edu login, and that will be your code. That refreshes every 30 seconds. You can only use it once. So if for some reason you mistype it or it doesn't take it the first time and asks again, wait 30 seconds and get a new code, because the current one will not work more than once. So once you log in, and this is true on both Cannon and it's just the address that you're SSHing to will be different. For Cannon, use login.rc.fas.harvard.edu. And if you need to log into FASSE for working with secure data, it's fasselogin.rc.fas.harvard.edu with your username. And I'll demonstrate that in just a minute. So here you see it asks for password, verification code. And once you're authenticated, you'll get some messages. Message of the day, please take a quick glance at those. They do change if we have announcements or things to let you know about. We have a reference to our documentation, so that's always handy. Let you know the next maintenance. This is an old slide, of course. And then some Slurm stats. It will give you a summary of jobs that you've run recently. So let's go ahead and try that. Do a little demonstration. So I use Putty. I'm on Windows. I have login.rc.fas saved with my username. Password and authentication code. And there we go. So the messages, we have maintenance coming up May 4th. There's a message about the user survey and the power outage coming up. And then summary of my recent Slurm jobs. And it'll be exactly the same on FASSE. I won't demonstrate that. And this just highlights to point out the prompt that you get at the end then gives your username at whatever node that you're on. So we have several different login nodes. And you'll see that the address that I put in was just login. And there's a round robin to distribute people so that everybody doesn't end up on the same node. It load balances to spread people out across the 6 or 8 different login nodes. And so once you're logged in and you get your prompt, then you find out what login node that you actually ended up on. So this one is Boss Login 02. That's in our Boston data center. You might also see Holy Login, which is at the Holyoke data center. Or on FASSE, you'll just see the FASSE login. You don't need to worry about too much about which particular login node that you're on. Just verify that it is a login node. So a reminder from our intro course, you may have seen this before. So now that you've logged into a login node from your local desktop or laptop, and you're at the login node, which is just, you'll have access to your home directory there and your lab storage, but you can't run any jobs here. The login nodes are for lightweight work, moving files around, checking profiles, things like that. Now we want to get onto the compute nodes for your heavy workloads. This just goes through the process that we just went through. So the reminders here, the login nodes are limited. Don't try to run anything with more than 1 core or 4 gigs of memory. Your job won't run or it will be killed. Don't do any analysis on the login nodes. No compute or memory. Basically, you just want to log in there, and that gives you access to the scheduler to get onto the compute nodes. And next, we're going to talk about now getting onto the compute nodes via an interactive job so that you can run testing and debugging and installing software using the salloc command. A reminder here, I'll just mention that. So when you're using an interactive job, you're a little bit susceptible to like network dropouts. We usually don't have too many problems with that, but just keep that in mind. You don't want to be running like long jobs on an interactive node just in case you get that network dropout. And also, if you start an interactive job and then let it idle for an hour, your session may freeze. I threw in some basic Linux commands. As you see, we're working on the command line. You have to type things in. So these are just very basic things to move into the directory or the file path where you want to work. Use CD or change directory. You can make new directories or folders with makedir. To see what's in a folder, it's ls. And to get help with any Linux command anytime, you use man, short for manual, and it'll pull up a screen of all the options on that command and how to use it. And then we're also going to be using text file editors. You can take your choice. You may be familiar with some, you may already know how to use them, but there's Vim, Emacs, and Nano. All of those are installed on the cluster, and it's basically what you're most comfortable with or more familiar with. I recommend checking out Software Carpentries. If you're not too familiar with all of the commands, of course, there's tons of commands. Check out Software Carpentry or some other source to review the Linux commands that you'll use to work on the command line. So now we're ready to actually start running some jobs. And as I mentioned, you use the salloc command. And when you're requesting a job, the most important things are what partition you need to use, how much memory, and how much time. So those are the essentials that you need to specify on with salloc. There are a lot of other options with Slurm that are in our documentation once you start realizing more specialized things that you need to do. But the basic, just to get on a compute node, will be partition, memory, and time. And once you do that, we'll go through a demo in a second. You'll see that the prompt changes from the login node to some sort of cryptic name. Again, that doesn't really mean too much to you. That's just assigned by like their location in the data center. Doesn't really mean anything except for this part. The holy part tells you that it's in the Holyoke data center. Of course, all the compute is at Holyoke. So you should always see holy something. And now you're here on the compute nodes, connected to all of your storage with the high-speed InfiniBand, so you can start doing some real work. Just a note, if you're on FASSE, interactive jobs are not allowed on FASSE, but you can get a terminal on FASSE through Open on Demand. And there you just go to the Open on Demand and select Remote Desktop. And once you're in Remote Desktop, you'll see a terminal that will give you a command line where you can run all the commands. So let's go back and let's try running salloc. So I use shortcuts here. Remember on the slide, these were spelled out as partition, time, and memory is the same, but you can use the shortcuts. I usually recommend typing things out to begin with, as they are on the slides, but here I'll just use the shortcut to save some typing. So that's submitted my request to the Slurm scheduler, and it's found a slot on the test partition for the job. And now you see I get this node name for the next 10 minutes. I only asked for 10 minutes. And you can start running commands. So interactive is a great way to start testing things. If you have Python code, just run some simple examples there just to make sure that your code is going to work. And then you can also use the interactive to start scaling things up. You start with a very small example of the actual workload that you need to do, see how much memory it takes, how much time that it takes, and then double your data size or something to see how it's going to scale, so that when you're ready to do a full production job, you know how much, the resources that you need to ask for. Once you've done that testing, then you can put all of the commands that you've tested in the interactive into a script and run it with the sbatch. And that way, you don't need to worry about those dropouts that I mentioned while you're on interactive. You submit your script to the scheduler. It follows all of these directives to find the slot, to find the nodes that you need. It might queue you for a little while until those resources are available. And then it'll run your jobs, run all of the commands that you need to run. So with sbatch, once you've submitted your script, then you can walk away, then you can lose the connection. It's in the scheduler and it's going to run on the cluster without the terminal. So you can automate things that way. You don't have to interact and you can close your laptop and it will run whenever it fits onto the cluster. So I've mentioned partitions. There are a number of partitions available on the cluster. We've been using test as an example for smaller jobs, but we also have larger jobs for multi-node instances, larger memory, and you can see the list of all the partitions on our running jobs doc. So we can try running a job real quick. I have some scripts set up in my home directory. This one will work. Yeah. So since we're still on the interactive node, let's check that job. So this is the one that's running. This one I think was from yesterday. But now let's just run this hello world.python. So in order to do that, first we need to load Python. And to find out what Python is available, you can use we already have a module for Python. We have all of these versions of Python available. So we need to tell this cluster that we want to use Python. To do that, we're just going to module load. I'm just going to say Python. That's going to pick up the default, the most recent version. Okay, so now we're ready. And now we can run our hello world script. And there we go. That's all it does. Hello world. So that's running an interactive job. Now, if we get out of that interactive session, back to the login node, we also have a batch job set up, which is called, oh, it put me back in my home directory. Okay. There it is. So I use VI. This is one of those editors. You can take your pick. So this is our batch script, similar to what's on the slide. I might have changed a couple things, such as the partition. We're going to try it on the Sapphire partition instead of test. Here I've said that we want 1 core for 30 minutes and 500 megabytes memory. I've also specified an output file and an error file, which you always want to include in your batch scripts so that you can, because you're not running it interactively, you won't see the screen, you won't get the output. You need to specify a file name to get output from your code or errors as well. So that's all the Slurm directives. That will set up the job, give us the allocation on the cluster, and then we can run the commands. So the same thing we did in interactive mode of loading the Python module. Don't need a Mamba environment in this case, but if you do, you would activate it here. You can print statements and then run your code. So if we submit that with sbatch, run script, you'll see it gave us a job number. So it has sent all of those instructions to the cluster. We could log out here if we wanted, and then the job will run when it comes up on the cluster. And that's where monitoring your job comes in. So we already checked the S account previously. Now if we check it again, we should see there's new job. So this is the one that we just submitted with sbatch, test job 1 on Sapphire. And we see it's already completed. So now we should have those output files. This is the one that we just ran. So if we look at, fortunately, so this is the error file, the .e. It's size 0, so that's good. There's no errors. And if we open this file, we can see our output. And there we go. This is our test Slurm script and hello world. So it ran successfully. So that's how to use S account to keep track of your jobs. Again, there's tons of options. So you can check out the documentation on all of the information that you can get from that, such as the memory usage. So if we want to find out how much memory that this job used, let me see if I can cut and paste from here. And substitute our job number, which was this. So this is a very small job. We requested 500 megabytes. We use 60 kilobytes. And you can change the units on that as well. For even more comprehensive information on the performance of your job and the efficiency, we just introduced job stats. So let's take a look at this job that we just did. And in this case, because it's such a small job, it doesn't give us that much information, but it will tell you a little bit about the efficiency. I can show you another job. Let's do the slides first, and then we'll come back to it, a larger job, and we'll check job stats on that. So that's after you run the job, you can run job stats on the command line to get information about that job. You can also have Slurm automatically email you the job stats after your job is done by adding this directive, sbatch. See a typo there. But anyway, just adding this mail type equals n, and then you'll get an email after your job is complete with the summary. And what job stats looks is all of the things that you requested, And then this nice bar of the utilization, how much CPU and memory that you used compared to what you requested and how much you were allocated. Some details about that, and then any notes. So let me go back. I can show you a specific example. Remember where I ran these. Okay. So this was a recent job. If we look at job stats on here, you get a lot more information. So again, a summary of what was requested, and then the total utilization for CPU and memory, and some details about the efficiency. And then here it adds notes. Because the CPU utilization was quite low, 26%, it gives you a note to highlight that, and then to give you some information on how to make that more efficient. We could have asked for a lot less, a lot fewer resources. And when you're working on testing in order to scale to your full production jobs, this will be useful information. And if you're working on GPUs, similar information, except it also adds GPU utilization and other helpful warnings and tips. As I mentioned, if you use that Slurm directive to get an email, you'll get the email. Also, you might have just received a notification yesterday that starting next week, you might get notifications from us on a weekly basis. If a lot of your jobs are inefficient, we try to offer tips to make them more efficient. You won't get those for every single job. We just are trying to highlight ways to make your jobs more efficient. So look out for those emails. Don't panic if you get one. We're not chastising you or anything. We're just trying to offer those tips to be more efficient. And you can always contact us for more information if you do get that email. Speaking of partitions, you can use the spart command to get a list of the partitions that you have access to. So we've seen test, we've run test, and we've seen Sapphire. The capabilities of each of the partitions are listed on our website. So I refer back to that all the time when you're choosing which partition that you need to use. And it depends on the requirements of your job, how many cores you need, whether you need CPUs and GPUs. The time limits also vary between the partitions and the number of nodes. For example, the big memory nodes, we don't have very many of them. So if your job requires a lot more memory, know that you're probably going to wait in the queue longer, because those have to be split between everybody on fewer nodes. The general purpose partitions, such as Sapphire, have a lot more nodes, and the requeue partitions have the most nodes, because those are a combination of basically all of the nodes on the cluster, even those owned by individual labs. If those nodes are idle, you can run your jobs there. Just be cautious that it's called requeue because your job can be requeued. If you end up on a lab owned partition and then somebody from that lab needs to run a job, your job can be preempted, which means it will be requeued, will restart again. But you need to build in checkpoints in your code so that it knows how to pick up cleanly. And we can work with you on setting those checkpoints, but strongly encourage you to use requeue. It costs a lot less on your fair share. So you'll be able to run more jobs, and the queue time is often a lot less on the requeue because it opens up all those extra queues. So that's the very basics of running jobs and monitoring your jobs and checking the efficiency. In order to run jobs, of course, you need to have the software available. And we've seen this module system like with loading Python. There are other software packages available in the modules. So if you're ever looking for a particular piece of software, that module avail that I showed you earlier, and also module spider will let you know if we already have modules. So for instance, if you're looking for MATLAB, you can use module spider MATLAB, and it will tell you if we have a MATLAB module and what versions we have. Other things like R, or I can't even think of any other ones right now. But if you have particular software, use module spider to see if we have it, and then you'll load the particular version that you want. Or you can find out other information about that module with the display. If you need to, this is mentioned specifically on Python, which we've talked about. But then, even though we have Python, you may need to install other packages. So we recommend using Mamba environments for that. And this documentation will walk you through that process. Always load the Python module first, and then you can create an environment and install all the packages that you need. And then when you go to run your job, you just activate that environment, and all of those packages will be available to your code. We recommend putting your Mamba environments in your shared lab storage rather than your home directory. First of all, some of those environments take up a lot of space, and you only have 100 gigabytes in your home directory. So it's better to use lab storage where you have more space. And also then you'll probably be sharing these environments with other people in your lab, and they cannot access it if it's in your home directory, but everybody in the lab can access things that's in the shared lab storage. So this is how to set that up. We also have a tool called SPAC that has a lot of software available. So if you're looking for something specific and it's not available with Conda, you can check SPAC as well to see if it's available there. And we have instructions for making SPAC available on your account and then installing software into it. And I think that's about it that I have running jobs. We do have an evaluation. If you can grab that URL and fill out a little survey about this training so that we can make improvements. Greatly appreciate that. And then also a reminder about our documentation for running jobs. I would recommend this GitHub user codes. There are a lot of recipes. In fact, we have plenty of time. We can take a look there at the kinds of things that are available. So we have examples of setting up of containers and different types of software for different languages and environments. There are libraries and frameworks and also examples, recipes that are commonly used so that you don't have to reinvent everything yourself. So if you want to set up job arrays or image processing, take a look here. What you need might already be here in user codes. Save you a little bit of work. And then finally, a reminder to check out our upcoming trainings. You just missed the Open On Demand one yesterday, and we don't currently have anything else scheduled. This is the last one for the spring, but we will have some more trainings coming up in a couple months, like over the summer and into the fall. You can also check out our training page for past trainings. And let's just look there too. That's under training. We have training materials for all of our previous trainings. There is somewhere in here is the advanced cluster usage, which does use that user codes with a lot of examples. And that was one of the jobs that I ran when we were looking at job stats. So that's where that came from. If you want to start thinking about advanced cluster usage, that's a good one. If you're thinking about VS Code, which is another way to interact with the cluster, it's almost a combination of the GUI interface with OOD and the command line. So if you've heard of VS Code, if you're already using VS Code, we have a training on that one. And then containers, lots of other things that you want to use. So with that, are there any questions?